right, so in this particular lecture, we're going to talk a little bit about wave properties. You've done a little bit of exploration probably with the waves on a string PhET simulation. So you kind of been introduced to some of the things that we're going to talk about today. So at the end of this lesson, you should be able to define a wave and define the frequency and wavelength of the wave. So those are two specific properties that are very important when we start to analyze these things. And we're also going to be able to distinguish between a transverse and a longitudinal wave. We'll talk about surface waves a little bit later, but maybe not today. So what is a wave? Now, probably when you first think of the word wave, you think of a water wave. That's usually what we think of because that's most common. Like that's something that we can see, and it's very easy to see that those are things that are moving through the water. A wave is excuse me. A wave is described as a disturbance or vibration that transmits energy, but not matter. But not matter is a really, really important point. So when you did your PhET simulation, you saw those little colored dots, and those colored dots did not move, right? They moved up and down. They were disturbed, but they were not moving with the wave. So if you look at these pictures here, you can see that water wave there in the middle. Over here just to the right of it, we see a sound wave. It looks a little bit different than those water waves, but you can kind of see the patterns there as well. Light travels in waves. We have waves that travel through the earth. So we have earthquakes, those seismic waves. And then this one down here, you might not have ever seen before. We've also discovered evidence that there are waves in space called gravitational waves. It's kind of fascinating to learn about that. Einstein was right. Again, go figure. So there's lots of different types of waves. These are just some examples. Some waves need to have a medium to move through them. All right. So, and what that means is there has to be some type of matter. So, like a water wave, for example, the medium is the water. So, when we disturb that water, we can see the energy moving through it. And that is what we mean when we say that the wave propagates through a medium, right? That energy moves through the water. And you have to have water in order for that to happen. Same thing with seismic waves, okay? You have to have some kind of solid, in this case, or liquid, to propagate those waves. So those waves can only move through some parts. Now, light waves are a little bit different. You do not need a medium. Light travels through space, so you do not need a medium for light waves to propagate. Now, there's two main types of waves that we're going to talk about today. And the first one is called a transverse wave. A transverse wave is what you normally think of. When you picture a wave in your head, this is probably what you see. And this is when the direction of the vibration of the wave is perpendicular to the direction of motion. So this wave right here is moving to the right. And so what is happening is the wave is moving the medium up and down. So the medium is moving at a right angle or perpendicular to the direction of the wave. So for example, light waves, radio waves, water waves. Again, water waves are things that you have seen. You've seen the water, you may have even felt the water if you're on a boat or out on a floaty, right? You may have even felt the water disturbing your equilibrium state and moving you in an up and down motion. Longitudinal waves, the direction of the vibration is parallel to the direction of motion. So think like an inchworm. So we have a compression here and we have a stretch here. We have a compression here and a stretch here. So you get this alternating pattern of stretching and compressing as the wave moves through the medium. So for example, sound waves, compression waves on a spring, or there are some types of seismic waves that travel in a longitudinal manner. Now this is taken from your PhET simulation. So this is a picture of a wave. And so if we look at the very, very top of the wave, we talked about how high or how low the wave goes. The highest point on a wave is called the crest. And as you can see, there's more than one crest. And that's probably something that you're familiar with. Again, if you've ever been around water, the wave crests. So the very, very top of the wave is called a crest. The very low point is called a trough. So we have this matter going up and we have the matter going down as well. So the top is called a crest and the bottom is called the trough. Now, if we were to measure this, so this is the water, for example, on a flat, calm day where there are no waves. If we were to measure from that point to the top of the crest, we call that the amplitude. And if we were to measure from that point to the bottom of the trough, that would also be called the amplitude. So this measurement here to the top of the wave and to the bottom, those are both the amplitude. If we measure one complete wave, like from trough to trough or crest to crest, or any point actually, so we could measure it from right here, as long as we have one complete wave. And one complete wave is one up and one down. So we have one down and one up. Okay, if we go from crest to crest, we have one down and one up. So one complete wave, the distance is measured in what we call a wavelength. Now this is just a regular length, so we measure that in meters. And we give it this little designation. This is the Greek letter lambda. So this upside down Y looking thing represents the wavelength of a wave. Oops. So again, we can measure that from any point. My clicker didn't click. So when we look at frequency is another property of waves that we want to talk about. Frequency is the number of waves that pass in 1 second. So if you're sitting on the dock and you measure the number of waves that go by the dock in 1 second, that is the frequency. So low frequencies have a low number of waves going by, and high frequencies have a high number of waves going by. And this is measured in what we call a hertz. Okay, so Hz is the abbreviation for the unit that we measure frequency in. Now, if we flip that over, the period of a wave is the time that it takes for one wave to go by. And that is measured in seconds. So if we take this one wave and measure the time, that's the period. If we measure how many waves go by in 1 second, that's the frequency. So we look at this wave right here, and this is 1 second. We have one wave, one complete wave going by in 1 second. So our frequency is going to be 1 hertz. Oops. If we look at this wave, okay, how many waves do we have going by in 1 second? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in this situation, we have 10 waves going by in 1 second. So we have a frequency of 1 hertz. Now, if we come back and we look at the period, okay, the time it takes for one wave to go by, well, this is kind of the same thing, right? So if we have one wave in 1 second, the period of that wave is going to be 1 second. Now, how long would it take one of these waves to go by? If 10 go by in 1 second, then we must have each wave going by in 1/10 of a second. Okay, so if we count how many waves there are in 1 second, and inverse that, right, flip it over, that's going to be our frequency, or our period. So these two things are the reciprocal of each other. Reciprocal just means it's flipped upside down. So the period of a wave is 1 over the frequency, and the frequency is 1 over the period. They're very, very closely related. So we take this example, a spring vibrates 24,000 times in 1 minute. What is the frequency? Now, frequency is how many waves go by in 1 second. So we have to kind of think about this. How many seconds do we have, right? We were given minutes. And 24,000 waves go by in that 1 minute. So if we have 24,000 waves going by in 60 seconds, we're going to take that 24,000 and we're going to divide it by 60. And that's going to give us a frequency of 400 hertz. So if we were to measure how many waves go by in 1 second, it would be 400. And that's the frequency. Now, what is the period of that wave? So if our frequency is 400 hertz, remember that the period is 1 over the frequency. So if we take the reciprocal of that 400, 1 divided by 400 is going to be 0.0025 seconds. So this is a lot of waves going by in a very short amount of time, right? That's not uncommon. So the period of the wave is a very, very short amount of time, but there's a lot of waves going by in 1 second.